Okay, so we are going to continue working with that RREF key, changing up our matrix system a little bit today, looking at some of those unique ones. So think back to Chapter 8 when we first started solving systems. We did the substitution method, we did the addition multiplication method, and we started out just with 2 equations, 2 variables, right? What happened when we added the equations together and we ended up with like 0 equals 5? What did that mean? We didn't have a solution to the system, right? That can happen. Even with larger systems, we can end up with those no solution types. We can end up with the kind that have infinitely many. So that's the focus today. What are those going to look like when we use a matrix to solve them? How are we going to know that it's a no solution or an infinitely many solution? Okay. All right, so I'm going to pause the video for a second. I want you guys to enter the first system here as a matrix and go ahead and use your RREF key. All right. And we'll see what we get for a solution. All right, so what did you end up with for your final column in your reduced row echelon? I'm assuming the left side is your identity matrix, right? Your diagonal of ones, everything else zeros. Okay, so what do you get for that last column?
-2, 1, 4.
Okay, agree, disagree? All right, so this is a system that had 3 variables and 3 equations, and we got a unique solution. Okay, that will not always happen. We can end up with no solutions and infinitely many solutions, but the only way to get a single answer is to have the same number of equations as variables. We're going to look at some systems today that don't have that. Okay? All right. Take a second. I'm going to have you enter the first matrix, or enter the first system as a matrix, an augmented matrix. Go ahead and give me your solution. Write it down here, and then do the second one. We're going to talk about how they're different, but I need you to get your answers for the 2. Okay? So go ahead and enter them. Use your RREF key and write down where it says matrix solution what your calculator is showing you. All right. First matrix that you got, solution's in here somewhere, maybe. Okay, how are the 2 answers different? In both cases, we had 3 variables, 3 equations. But if we start interpreting what the lines mean, this top row says we have 1x plus 1z equaling 0. Yes? Okay, so 1x plus 1z equals 0. Second one says 1y plus 1z equals 0. Yes? So that means x and z have to be opposites, right, to cancel out. Y and z have to be opposites to cancel out. But what does the bottom row tell us? 0 equals 1. Can 0 equal 1? No, that's that false statement that we got back in Chapter 8, right, when we were solving a system and we got things like 0 equals 5. So that can't be. So if we get a false statement, all right, like this 0 equals 1, that tells me I have no solution. I cannot solve this question, this system. Okay? So it's going to be really important that you pay close attention because there's going to be lots of 1s and 0s on the left part of the matrix. All right? Look at that bottom row before you start working with anything. All right? So if we get a system like that, we're going to say there's no solution, just that 0 with a line through. Okay? Now, how is the second example different?
Infinitely many solutions because the bottom is true.
Our bottom row there is different from the previous example. Okay? That's why I said always look at that bottom row to see, do you have an answer for z? Okay? In all the ones we've done up till now, you had an answer, right? Z equals 2. You got a solution. You could back substitute it to solve it. Here, we don't have a solution for z. But we do have a true statement. 0 does equal 0. That means We can find solutions. There's just not a single one. There's an infinite number. And in the last chapter, when you got an infinite answer, I said you need to state the equation, right? There's infinitely many solutions such that, and you gave me an equation like y equals 2x plus 5. Because there's not, it doesn't mean all solutions work. It just means there's an infinite number of ones that do. So you had to state the criteria of what would make it workable, right? We have to do the same thing here. So we're going to go back and we're going to interpret what these rows mean. My variables were in the order x, y, and z. So my top row says I have 1x minus 12z's equaling 1. My second row says I have 1y minus 10z equaling negative 1. Okay, so how I interpret that, I'm going to have to take my top two rows and I'm going to have to solve for x and y. Okay, so this top one, if I wanted to solve for x, can I just add the 12z to the other side? So I'm going to get an expression here, x equals 12z plus 1. My second row, if I were to solve it for y, I'd have to add the 10z to the other side. And the bottom row, what this tells me is that z can be anything. Okay? So how I'm going to write my solution is just with expressions in there. Okay? So x we said was 12z plus 1. I'm going to put that where the x would go in my ordered triple. Okay? Y is equal to 10z minus 1. So that goes in the y position. And the last one is just a plain z because z can be anything. Okay? So when you get an infinite number of solutions, you're going to have an ordered triple like this that just has variables in it or expressions with that variable. Everything should be in terms of z because we said z can be anything. So now I could say, based on that, give me a solution that works. So you could pick a number for z. Let's say we pick, we'll make it easy, we pick 0. Okay? I put a 0 in here for z. I put a 0 in here for z, I get negative 1. I put a 0 in here for z, I get positive 1. That's one possible solution that works. But I could pick anything for z. I could pick 20 million, dump it in, and get my other two variables. Okay? So when we get an infinite number of solutions, you're going to have just expressions in your answer, not a single number. Okay? Graphically, what it is we're finding. When we solved the system and we found one solution, like our review question today, that's the first picture. We're finding a spot where all three intersect. There's one point where all three dimensions meet. Okay? If I get no solution or an inconsistent system, that means all three equations don't meet anywhere. You might have some that overlap, like in our first picture here. Okay, some overlap, but not all three together. Here, none of them overlap. Okay, those two pictures would represent that there's no solution to that system. Okay, there's no ordered triple that fits everything. Our last picture is our infinitely many. And remember, when we draw these planes like this, we're representing a plane, but remember from geometry, it extends forever, right? It's not just a sheet of paper, it's a huge plane. So every point on this line, and it's going to continue, all of those points work in that system. So that's your infinitely many version. Okay? All right, so shifting now to ones that we call non-square. That means the number of variables don't match the number of equations. In this situation, you will never get a single answer. Okay? If I want to get a single answer, I have to have enough equations to find it. I don't have enough equations here. Okay? I have 3 variables, but only 2 equations. We're going to set up an augmented matrix. What size would it be? Okay. So we're going to set up a 2 by 4 matrix. My top row would be 3, 7, 6, 26. Second row would be 1, 2, 1, and 8. Okay? So go ahead and enter that as an augmented matrix in your calculator. Go ahead and do your RREF and write down what you get. Okay, does that look correct? There is no bottom row. We don't have enough equations to solve the system. So this is another one where we're going to get an infinite number. We're going to say z can be whatever we want it to be. Okay? So looking at the order of our variables, our first one was x, right? Then y, then z. So my top equation says 1x minus 5z's equals 4. And my second equation says 1y plus 3z's equals 2. Okay? So if we were to solve those for x and y, I'd have to add the 5z over, I'd have to subtract the 3z in the second one. Okay? So what it's going to look like when I interpret it, I've got x equaling 5z plus 4. I've got y equaling negative 3z plus 2. Okay? So I'm going to put 5z plus 4 in where my x would go. I'm going to put negative 3z plus 2 in for y, and I'm going to let z be z. Okay? Now, for these non-square ones, remember we didn't have a third row, right, that gave us 0 equals 0. Sometimes your book will convert that. They'll say, well, if z can be anything, I'm going to pick a different letter for it to be. I'm going to say, I want z to be t. Okay? And so they might write the solution with a t here, substituting basically a t for all your z's. So your book might give the answer as 5t plus 4, negative 3t plus 2, and t. Okay? You don't have to change them to t's. I'm just pointing it out because they're saying z can be anything. We can change it to a different letter. All right? You don't have to do that, but if you're checking your answer and you're going, where did this t come from? That's why. Okay? Questions so far? Okay. Next one. Go ahead and enter it as a matrix. And use your RREF. All right, checking our solution. Maybe we're checking our solution. Okay, try this again. Okay, we got our solution. Top row says we have an x minus a z equaling 50. Second row says we have y plus 2z equaling 10. Yes? So my answer, again, you can leave it as a z. You don't have to change it to t. So you should have z plus 50, negative 2z plus 10, and z. Yes? Okay. So keep in mind, you have to get it all the way to this line, right, as your solution. You can't just stop here. Okay? All right. We're going to look at two larger ones. How many variables do we have in this next one? 4. How many equations do we have? 4. So we might get a solution to this. Okay, we have enough equations that if the system works, we can get an answer. All right, go ahead and put it in as an augmented matrix. You will get some decimals or fractions on this one. All right, so when you got your final matrix, you had some decimals, yes? What did your bottom row show you?
0 equals 1.
Your bottom row should have showed you a 0 equals 1. Okay. All right. So what I would expect to see for your work on this, all right, if this was a test question, You don't necessarily have to show me the matrix you're putting into your calculator. You need to show me the matrix you're getting out. However, if you tend to make mistakes, I would strongly encourage you to write down your first matrix. That way I can see, oh, you just dropped a negative sign, but you knew the right process. Does that make sense? All right, so we put this in as our augmented matrix. We got this one out. Our bottom row, which is the first row you should always look at, all right, our bottom row gives us a false statement, which means no solution. Okay. Go ahead and enter this one. Will we get a solution here? Can we get a single answer? Can we get a single solution? How many variables do we have? 4. How many equations do we have? 3. We can't get a single solution. So it's going to be either no solution or infinitely many. Okay? All right, so we've got our solution here. We notice our order of the variables. This first one is W, then X, then Y, then Z. So my top row tells me that 1W minus a Z equals 3. Yes? So from that, I can write W equals Z plus 3. Okay. Second row says I have a X minus 5Z, and I should equal a 5. So I can add the 5Z over, so X is 5Z plus 5. And then my third row says I have a Y minus 3Z equaling 4. So adding the 3Z over, Y equals 3Z plus 4. And Z can be anything. Okay? So my ordered quadruple in this case, again, they changed them to T's. You don't have to. So Z plus 3, 5Z plus 5, 3Z plus 4, and Z. Okay? Questions? So the new part here is just making sure that you know how to interpret your solution. Okay? Really look at that bottom row to make sure you have solutions before you do a lot of work. All right. Your assignment's on page 885. You're doing 1 through 21, but you can skip number 19. Sorry, 1 through 21 odd. Skip number 19. Obviously, I need more than just a single answer because that's in the back of the book. So you're going to show me the matrix you get. Yes? And then you're going to interpret it if it's an infinite one.